Alright kids, here we go. Here's another FF prime and F double prime problem. Again, you're going to see these on your free response question of your AP exam. So without further ado, let's go ahead and get started with this. Okay, this one says the graph of the function f consists of three lines. Can't even talk today. Consisting of three line segments given above. Can't read either apparently. Let g of x equal to the integral from 1 to x of f of t dt, and it says compute g of 4. So first thing I want to do is I want to write down what g of x is. I know that g of x is equal to the integral from 1 to x of f of t dt. If I want to find out what g of 4 is, that x is replaced with 4, so wherever I see an x over here, I'm going to replace it with 4. So we have to integrate from 1 to 4 of f of t dt. And so if I integrate from 1 to 4 of f of t dt, that means I need to find the area that's above the x-axis and subtract the area that's below the x-axis. And so if you can see, I can find this area right in here, and you'll notice that the area of this triangle and this triangle are going to be the exact same, but since one's above the x-axis and one's below the x-axis, they're going to cancel each other out. So in essence, what I just have to do is find the area of this thing. And this thing right here is going to be a trapezoid, and you have to look at it like this to make it look like a trapezoid that we used to. So it's going to be 1/2 the base, or 1/2 the height, which is 1, times the two bases added together. If you remember, the bases on the parallel or on a trapezoid are the parallel sides added together. So we have this height is 4 plus this height, which is 1. So we come up with 5/2. That's what g of 4 is equal to. If I want to find g of -2, again, wherever I see an x, I'm going to replace it with -2. So we have g of -2 is equal to the integral from 1 to -2 of f of t dt. Since this upper limit is bigger than this lower limit, you can flip the limits and it becomes a negative of the integral. So from -2 to 1 of f of t dt. And so now we're going to do the exact same thing that we did at this problem. We're going to have to find the area that's trapped between the x-axis from -2 to 1. So from -2 to 1, the area that's trapped between the x-axis is this triangle. And to find the area of this triangle, it's going to be equal to 1/2. The base is 1, 2, 3. And the height is going to be a +4. Now one thing that was kind of tricky that I kind of skimmed over is this negative. This negative is going to be out here because we flip the limits around. Alright, so we come up with a, I don't know, -6. So this value is -6. Okay, let's look at this problem. It says we want the instantaneous rate of change. Well, way back in chapter 3 when we were doing derivatives, we know that the instantaneous rate of change is the same thing as the derivative. This is equal to the first derivative. So I know that g of x is equal to the integral from 1 to x of f of t dt. So if I want the instantaneous rate of change, I have to find g prime of x. And now you're going to take the derivative of this thing. And in order to take the derivative of this thing, you're going to use the fundamental theorem of calculus, which says when you're taking the derivative of the integral, you have this upper limit that you can just plug into here. You can only do this if this is a variable, and you're taking the derivative with respect to x. So this is just going to be f of x. Now, g prime of 1 is equivalent to f of 1. And now I need to find out what f of 1 is. Well, what's f? Well, f is this function here, and f of 1 is going to equal to 4. So that value is 4. Okay, let's continue on. The C question says, I want the absolute minimum of g. All these problems are the same. I see the absolute minimum of g. So min of g, that means take the derivative of g and set it equal to 0. So take g prime and set it equal to 0. So I know that g of x is equal to the integral from 1 to x of f of t dt. So if I take the derivative of g, which is g prime, again, back to the fundamental theorem of calculus, that's going to be f of x. Now I'm going to do line justification. So if I have f, and I look to see where f is equal to 0 at, it occurs at 3. So we have 4, and this is negative 2. So I know that if we look at f, which is equivalent to g prime, I guess I could state this, I have from negative 2 to positive 3, f is positive because it's above the x-axis, and from here to here it's negative. So we have the absolute maximum, or we want the absolute minimum. So the absolute minimum can occur at negative 2 or it can occur at 4. So we can say g's absolute min occurs at x equals negative 2 or x equals 4. So what that means is I need to find g of negative 2 and I need to find out what g of 4 is. And whichever value is bigger, or whichever value is smaller, that's going to be your absolute minimum. So g of negative 2, hey, we did that. That value is negative 6 from part A. And g of 4, hey, we did that one too. That's from part A, and that value is 5/2. So we can say g's absolute minimum value is equal to a negative 6. All right, let's look at the next one. It says the second derivative of g is not defined at x equals 1 and x equals 2. How many of these x coordinates are points of inflection on the graph of g? Justify your answer. Okay, so I see the second derivative of g. Well, again, I'm going to rewrite this business down. I know that g of x is equal to the integral from 1 to x of f of t dt. G prime of x is equal to f of x, and g double prime of x is equal to f prime of x. You don't have to do this on these problems, but I'm doing this just to re-emphasize what we're doing here. Now I need to look at g double prime, which is equal to f prime, from negative 2 to 4. And I see that we have one at 1 and at 2. So now what we're going to do is we're going to look at the slopes. So from negative 2, because that's what f prime is, that's going to be the slopes of g. So if I look at the slopes from negative 2 to positive 1, the slopes are positive. From 1 to 2, the slopes are negative. And also from 2 to 4, the slopes are negative. So since we're dealing with the second derivative, that deals with concavity. And I know that g is concave up here, g is concave down, and it's concave down. So the only point of inflection we're going to have is at x equals 1. So we can say that g's only inflection point is at x equals 1, because, and it just does say justify your answer, and here's the reasoning why. You're going to say because g prime is increasing, from negative 2 to 1, and g prime is decreasing from 1 to 2 union 2 to 4. Therefore, the only inflection point is at x equals 1. All right, and there you go. Hope that helps. Bye.